Hello and welcome to Econauts. My name is Simon and I'm here with my brother Ben, the Rocket Man.
Hello.
Um, all right, we are talking about science, space, and economy, and our topic today is space mining. My first question to you: what is space mining?
Well, space mining can mean a lot of things, but conceptually, it is finding and utilizing resources in space. That's space mining. So
All
can
right.
go from sending a drill rig onto a meteor to catching a cloud of stardust.
Oh, really? Even catching a cloud of stardust?
Yeah, conceptually, yeah.
Okay, all right. Um, then the next question is: why should we do space mining?
I guess this is a bit of a wider question or wider answer to give. The initial response for many people would be, "Oh, let's find a ginormous asteroid of gold or a big diamond or whatnot," and they think they would make billions and billions of dollars bringing that back. Um, I can almost certainly say this is not the case, because what happens when you spend millions, hundreds of millions of dollars to find and then collect and secure such an asteroid and bring it back into Earth orbit. And now suddenly you have a billion ton of gold floating around orbit. What happens with the gold price on Earth? So suddenly,
Yeah,
suddenly it's worth nothing anymore. So
yeah.
yeah, but I guess the why, as humanity, we want to explore. We should explore the universe. We should extend our reach out of Earth, not only to solve problems on Earth, but also as a species. In hundreds and thousands of years, we need to be sure that we still exist. That means, like Elon Musk wants to go to Mars, we need to become interplanetary, maybe even interstellar as a species. And in order to do so, we are dependent on many resources. That goes from simple minerals such as iron and others to build things, to more substantial resources such as water. Um, and water is the main resource we are looking for and aiming for. So the Moon to Mars initiative from NASA, for example, is looking for water on the moon for that exact reason, because water as importance, um, or the importance of water is because we need it to sustain life for us, to drink, to make oxygen and hydrogen out of it, and the oxygen obviously to breathe, the hydrogen as energy carrier, and also as propellant. So that it's actually quite important. And then I mentioned that in the other episode as well. There's also other materials we can mine or gather from other celestial bodies. The moon, for example, has plenty of helium-3 in the regolith, which we can extract with quite simple methods. And then if we would have a logistical sustainable highway to the moon, we could bring it back to Earth and then do fusion with it and whatnot.
Yeah. Um, I actually had a question. What material should we mine? You already started answering that. I I absolutely understand that water should be a priority for reasons that we touched on our last show as well, last episode as well. Um, like you already said, we can have like oxygen and hydrogen and also the water itself, um, you know, uh, um, to sustain life. But what else? What other materials should we mine so that we can maybe? So for me, what I think is if we need iron, it makes more sense to take the iron from an asteroid, and because it's already in low gravity, there's no gravity at all, which means that it takes less energy to get the iron to a spaceport in spaceport.
Mhm.
There it
Yeah.
is again, the space
Yep.
spaceport. Uh, um, And then we can also, if we have a space dock and want to build like larger ships, then it makes sense to have like all the material there. So
Yeah.
so what would be after we have you know maybe water for the space station? What else would be desirable to actually mine?
Yeah, I mean,
And realistic too.
realistic is anything really, anything which floats in space. So as soon as we can catch it somehow, we can technically we could bring it to another orbit, or we could bring something there and bring something back, which makes less sense. And also, maybe one thing I should mention, just for the assumption, I think here in longer time scales. That's nothing which we can achieve in like 3 years. That's something we can
Obviously.
achieve, right? That's something we can achieve over a century, and as an effort of us as a human species. And if you think of these time scales, you could bring back material such as iron and so on. And the spectrum of materials we would need is actually quite wide. It's not just the one thing. It's not just iron, or it's not just copper. It's not just that. We need everything we would need to build a whole spaceship. Because as you already mentioned, it
Right.
is expensive in terms of energy expense to launch and propel things from our surface into orbit. More expensive than if we would have already somewhere, parked meteors and asteroids full of all the materials we would need, and we just have to be there and build our dock close by them so that we can just harvest it. Um,
Yeah.
and then anything you would need, like iron to make steel. You need hydrogen and oxygen for many processes. You need copper for cables. You need silica for solar panels, and so on. There will be many things you would need, and ideally you want them in orbit or somewhere outside of the surface of the planet, of a planet,
Yeah.
to use it to use it in situ.
We already talked about that too. If we have like robots and AI actually helping us out, what we in theory. So this is I'm of course looking at that from the perspective of someone who was like watching Star Trek a lot. So for me, what I see is like if we have like a refinery, for example, it doesn't matter if it's on the moon or it's in orbit. Doesn't matter. If we send from that refinery drones, I just say drones, and send them to mine an asteroid. They bring that back to the refinery. The refined material can then be used to make more drones that can be sent out to actually this is how I see that, right. um, Basically like a snowball effect. And and that's not even too far fetched if we look at our own history. I mean, we started in the Stone Age, and it slowly went into the Bronze Age, and slowly, Middle Ages, and at some point we had like the Industrial Revolution, and now if we look at ourselves, we basically are connected with the entire world over the internet, and have social media and all those things available to us. So it's not too far fetched to assume that if we build something in space, that this has a snowball effect as well. Would you
Yeah,
agree with that?
absolutely. Maybe not. Maybe it's not drones, or maybe it's not artificial intelligence or whatnot. But who knows, right? So who knows?
For
The
for,
drive,
for
though.
me, sorry, for me, when I talk about robots and artificial intelligence, I obviously I have an IT background, as you know, and for me, AI is like the software, and the robot is the hardware,
No,
right?
absolutely. No,
So
I'm not. I'm
right,
not saying that. What I mean is maybe they would not reproduce themselves, and we would still be involved in some form or shape. I'm just
that's what
saying
I think as well.
there's
Yeah, yeah.
many possibilities, obviously. Um, so one good example is NASA Artemis, the Moon to Mars initiative, um, and although the goal is to bring back humans to the moon and also build a permanent base on the moon, to sustain a human presence permanently there. Still, the vision of many people, and also the push to achieve that is through robots and remote operated vehicles. Vipers, for example, a very good example from NASA, which is a exploring vehicle to find water on the lunar surface. So definitely robots, and also speaking of bigger time scales, obviously the time scale or the lifespan of one human, let's say, is 100 years, right? Maximum, or which is already quite large. But then also in the 100 years, there's time where you're a kid and so on. So you don't have 100 years to actually do something. So a robot obviously has, if you build it correctly, and if it can maybe even maintain itself or even reproduce and make more, would have a longer time span to actually achieve a mission. Look
Right.
at Voyager 1 and 2. They have been launched in the 70s, and they have left the solar system now, like a couple of years back, actually. But they are old, and it's also old technology. So that's the disadvantage, sending something for longer periods, right? So the technology on board is getting old and outdated.
Yeah, at some point we may have like spaceships with warp capability, and then we can just catch them again. Voyager 1 and 2. Hi, it's us. Yeah, okay. Well, thank you so much for your time. I hope you liked this episode, and if you do, leave a like. Don't forget to subscribe, and we'll catch you next time.
See you
Thank
next
you
time.
very much.
Bye.
Bye bye.